Hi guys. Today we're going to be looking at selection graphs and selection pressures in natural selection. So a selection pressure is an external agent, think something in the environment that can affect an organism's ability to survive. So um, it is what changes in the environment that pushes that organism to change through natural selection. So selection pressures can be for or against a trait. If it's for a trait, that trait helps increase the fitness and increase the survival of the organism, so that trait will become more common. So if we select for a trait, it becomes more common. If the pressure is against the trait, for some reason, that trait must make it harder to survive and reproduce, reducing the fitness. And so that trait is going to become less common. It might even disappear. So when we select against a trait, it becomes less common. So in natural selection, in these graphs, we're going to be looking at traits that are considered polygenic, which means they have a range of phenotypes. So these are controlled by many genes, so their outcomes are varied. So for instance, we've looked at beat depth. Um, it has a range of beak depth from very small, maybe 5 to 6 millimeters, to much larger, 13 or 14 millimeters. So there's a range of traits that we see, not just big, small. And so polygenic traits just have a range of phenotypes. So other examples would be your hair color, maybe eye color or skin color, even height would be polygenic traits. So there's a little bit of vocab that you need to know when it comes to these graphs, and they're very simple. On either side, the traits that are on either side, so for the bird beak, it'd be 6 or 13 millimeters. Those are considered the extremes. And notice that not a lot of organisms typically have the extremes. And then in the middle, we call that the intermediate or the average. And so more individuals have that intermediate or average trait. So you tend to see a bell curve of sorts when we look at these types of traits. And so what we're going to do is we're going to look at how natural selection um, changes these graphs in 3 different ways. So the first way it can change um, these graphs or a population is called directional selection. So in directional selection, we have one of the extremes that is selected for, or one of the extremes is favored. Meaning on one end of the graph, there's a trait that makes it easier to survive and reproduce. And so that trait is going to become more common. So when we're looking at these moths, if there was a change in the environment where the trees became darker, we would see an increase in the moths that are darker and a decrease or a decline in the number of moths that are lighter. So our changed graph would move in one direction. Notice now the intermediate is higher where the darker moths are. And so our graph shifted towards the one extreme in one direction. And so this is considered directional selection when one extreme is more favored, is selected for. This is another example, and so in this example, if the mice, for whatever reason, it's better to be white, let's say it's a wintry time or a wintry climate, you would see an increase in the number of white mice, or the lighter colored mice, and a decrease in the darker colored. So you'll see the graph move, and in this case it's a bar chart, but it's still moving in the direction of the lighter mouse. So this is directional selection. The second type is called stabilizing. And in stabilizing selection, the average is selected for. So the average is favored, and the extremes are selected against. And so the average trait must increase the fitness of those individuals. It must be you're more able to survive and reproduce if you have that average or the intermediate trait. And so those individuals will increase while the other ones will decrease. So for instance, in this scenario, if you have too few or too many eggs, the birds have less of a chance of surviving. Whereas if you have an average number of eggs, the birds have a higher chance of surviving. So with stabilizing selection, we'll see a new graph in which the average number goes up. So we have more individuals with the average trait and less with the selection decreases variation in the population, and in terms of natural selection, it can be a harmful thing. All right, one other example of stabilizing, and this one, if it's better for the horses to have an average height, then you'll see an increase in those and a decrease in the horses with the other height. So again, you'll see more average after stabilizing selection. All right, the last one's my favorite. It's called disruptive selection. In disruptive selection, both of the extremes are favored for, or they are selected for, and the intermediate is actually selected against. So it's bad to be average. So what happens is we will see an increase in the extremes because they're able to survive and reproduce, but we'll see a decline in the average. So our graph changes rather dramatically. It's almost as if we smack the center down and the sides pop up. So this is disruptive selection. And again, the intermediate is selected against, while the extremes are both selected for, so they both survive, which is why we see an increase in their numbers. So if that were to happen with the bird's beak, we might see something like this, where the intermediate beak declines and the two extremes increase. So one last time, directional moves the graph towards one extreme in one direction. Disruptive decreases the intermediate. The intermediate is selected against, the extremes go up. And in stabilizing, the intermediate goes up and becomes more prevalent. All right, so we're going to have some questions here now. So in this graph, notice that the selection is against both extremes and for the intermediate. So go ahead and answer the question in the Edpuzzle now. If you selected stabilizing, you're correct because the intermediate is the best and we're seeing that average trait increase. All right, what about this graph? Answer the question in the Edpuzzle now. If you selected disruptive, you were correct because in this one, both extremes are favored, so they increase, and in that dotted line, you see the average going down. It's selected against. One last graph. If you selected directional, you are correct because we're moving the graph in one direction, towards one extreme. We're favoring one extreme or selecting for one extreme, which increases the fitness of the organism. All right, so now it's time for some scenarios. So in these questions, you're going to read the scenario and answer the question in the Edpuzzle, and then I'll go over the answers. So go ahead and answer the question in the Edpuzzle now. All right, if you selected, in this case, directional, you are correct because we had a range of tail feathers from a few to a lot, but the extreme, having a lot of tail feathers, was the best. So we shifted towards having a lot of tail feathers, and so that is directional selection. So again, having a lot of tail feathers allowed them to survive and reproduce. It was selected for. One extreme was selected for. All right, go ahead and try this example now. Okay, in this one, if you selected disruptive, you are correct because both light and dark rabbits, so the white and the black colors, were able to survive and reproduce. So they went up, whereas those gray bunnies, their population declined because they weren't able to camouflage anymore. So this is disruptive selection. Go ahead and try this one about cockroaches. Okay, if you selected in this one directional, you would be correct because we are selecting, and I have a lot of kids who are confused about this one. We're eating the small and the medium-sized adults. So when you're eating something, that's a bad trait to have. That's being selected against by nature. And so small and medium-sized adults are declining the larger cockroaches, those ones are surviving. And so that's the good trait to have. We're selecting for large cockroaches. So we're going to move the population towards being larger in size. So don't get confused by what is being eaten. Instead, what we're looking for is something to survive. That's what's being selected for. That's what's good. All right, in the last one, go ahead and read this one and answer this question. All right, if you selected stabilizing this one, you were correct, because if having too small or too large wings was hard, it made it harder for you to survive. So having the average size wing made it possible for you to survive and reproduce. And so we see an increase in that average intermediate trait. So that is stabilizing selection. All right, that's all I have for you. So have a great day.